Have you ever looked up at the night sky and felt a sense of wonder? All those twinkling stars, billions of them, each a sun in its own right. But have you ever wondered what happens when all that light goes out? What will the universe look like trillions and trillions of years from now, when the very last star finally fades to black? This isn't a story of cosmic doom and gloom. It's a story of ultimate transformation, a journey into the deep future to witness the universe's final, quiet moments of light. To understand the end, we have to start at the beginning. Right now, we live in what astronomers call the stelliferous era, the age of stars. It's a vibrant, brilliant time. Giant clouds of gas and dust collapse under their own gravity, igniting into the fiery balls we call stars. Our own sun is a perfect example, happily fusing hydrogen into helium, bathing our planet in light and warmth. This process powers everything we see, from the smallest, dimmest red dwarfs to the colossal blue giants. The universe is ablaze with the light of stellar furnaces. For the next few trillion years, this cosmic fireworks show will continue. New stars will be born, live out their lives, and die, seeding the cosmos with the heavy elements needed for new stars, new planets, and maybe even new life. It's a beautiful, dynamic cycle. But nothing lasts forever, not even the stars. As we move forward in time, the universe keeps expanding. The vast clouds of gas and dust that are the stellar nurseries of today will become stretched thin, too sparse to form new stars. The era of star birth will slowly, inexorably come to an end. The stars that already exist will begin to die out, one by one. The most massive stars will have already gone out in spectacular supernova explosions, leaving behind exotic remnants like neutron stars or black holes. Stars like our sun will swell into red giants, shed their outer layers, and then cool down into faint, dense white dwarfs. This marks the beginning of the next great cosmic epoch, the degenerate era. Imagine a universe where the only lights left are the fading embers of dead stars. This is the degenerate era. The sky is no longer filled with twinkling points of light. Instead, it's an almost perfect black, punctuated by the faint, ghostly glow of white dwarfs, the ultra-dense cores of sun-like stars. These stellar ghosts will be the dominant objects in the universe for an almost unimaginable length of time. They start out incredibly hot, but with no fuel left to burn, they will spend trillions upon trillions of years just cooling down, slowly radiating away their residual heat into the cold, empty void. Over timescales that dwarf the current age of the universe, these white dwarfs will cool from brilliant white to yellow, then to orange, and finally to a dim red. Eventually, they will fade entirely, becoming cold, dead spheres of crystallized carbon and oxygen, essentially giant diamonds floating in space. We call these hypothetical objects black dwarfs. But here's where our story of the last light gets really interesting. Even in this darkening universe, there's still a chance for a final spectacular burst of light. White dwarfs are incredibly dense. Sometimes, two of them, locked in a gravitational dance for eons, will spiral closer and closer together. What happens when they finally collide? If their combined mass is just right, a little over 1.4 times the mass of our sun, the collision can trigger a runaway thermonuclear reaction. The result is a type Ia supernova. For a few brilliant weeks, a single point in the vast, dark universe will blaze with the light of 1 billion suns. This will be the last true firework of the cosmos, a final, magnificent gasp of stellar light in the degenerate era. These events will be incredibly rare, happening maybe once every few quintillion years in a galaxy like ours, but they will be the last stars to shine. So, is that it? After the last white dwarf cools and the last supernova fades, is the universe plunged into eternal, absolute darkness? Not quite. There's another, much stranger and much slower source of light still to come. The universe will enter what's known as the black hole era. By this point, galaxies will have dissolved, and the dominant objects will be black holes. Even black dwarfs will eventually be gone, thanks to a theoretical process called proton decay. Over truly staggering timescales, think 10 to the power of 40 years or more, the very protons that make up matter might fall apart. As these black dwarfs slowly evaporate into a sea of subatomic particles, they will release a tiny, tiny amount of energy. It's not much, but it's a form of light. The real stars of this era, however, are the black holes themselves. Thanks to Stephen Hawking, we know that black holes aren't completely black. They emit a faint thermal glow known as Hawking radiation. For a solar mass black hole, this radiation is incredibly weak, far colder than the background temperature of the universe today. But as the universe continues to expand and cool, this faint glow will eventually be the hottest thing around. A black hole will slowly, very slowly, evaporate over eons. The smaller the black hole, the faster it evaporates. The process is incredibly long. A stellar mass black hole will take about 10 to the power of 67 years to disappear. The supermassive black holes at the centers of galaxies? They could last for 10 to the power of 100 years, a number so large it's almost meaningless. As a black hole reaches the very end of its life, the evaporation process accelerates dramatically. In its final seconds, it will release its remaining mass in a final, powerful flash of high-energy gamma rays and particles. This will be the very last light in the universe. A final, solitary pop of energy in the endless, cold darkness. After the last black hole evaporates, the universe will enter its final state, the so-called dark era. It will be a near-perfect vacuum, a vast, cold, and empty space filled with only a diffuse sea of photons, neutrinos, and other fundamental particles, all drifting ever farther apart as the universe continues to expand. There will be no structure, no heat, no life, and no more light. The cosmic story will have reached its quiet, final end. It's a mind-bending thought, isn't it? That all the brilliance and complexity we see around us will one day fade into a quiet, simple state of cold and darkness. But there's a strange beauty in it, too. It shows us how precious this current moment is, this vibrant, light-filled, stelliferous era. We are lucky enough to exist in a time when the universe is alive with the fire of stars, when we can look up and see a sky full of wonder. The story of the universe's last light isn't just about the end. It's a reminder to appreciate the brilliant cosmic noon in which we live. The lights are on, the show is in full swing, and we have front row seats. Thank you so much for joining me on this journey into the deep future. If you found this as fascinating as I do, be sure to hit that like button and subscribe for more explorations into the cosmos. Let me know in the comments what cosmic mystery you'd like to explore next. Until then, keep looking up.